Q1 minus 1/3 Vz over B equal to 0. So now we get an interesting equation. 4Q1 equals minus 1/3 Vz over B, or Q1 equal to minus 112. So Q1 is not 0 for this case. So we have solved for Q1. So we know the shear force. Shear force is known. Okay. Only the location is not known. B is known. So we solve for the shear flow, then we can find all the shear flow. So basically we are getting a negative shear flow. See that? That means actually Q1 is this way. The correct direction. Q3 is going to be this. Then I have to, you can calculate Q2 and Q3 if you want. Let's do that. Q2 will be what? Q1 plus 2/3 Vz over B. What it will be? Quickly, anybody? 2/3 will be 8, 7, 2. Good people. And then finally Q4 will be Q1 minus 1/3. So it will be minus.
Should Q1 and 3 be the same direction? Should they equal?
What is that?
Shouldn't Q1 and Q3 be the same direction?
No, Q1 is always opposite to Q3. Q1 equal to Q3. Yeah, so Q1 equal to Q3 magnitude. So Q3 will be, the question was Q1 equal to Q3, agree. So it should be minus 1/12 of VCB. The minus sign means, this is the assumed direction Q3. Remember, they have to always cancel. There's no net. And finally, I come to this. Q1 is minus 1/12. This is minus 4/12 minus 5/12. I don't know why. Oh, it makes sense. Does it? Yeah. I get Q4 is negative. Okay. So Q2 is 7/12. 7/12 of VCB. Whereas this is minus 5/12. So going down, originally assumed it has to go upwards 5/12. Again, it balances. 7 plus 5 is 12. So the total shear force VZ is equal to that balances. Now, finally, we have to find the distance EY. I'm going to take a moment about again, which one you want to do? You want to do the centroid? Because you can get directly EY. Let's take a moment to go to the centroid. Take moments about the centroid of the whole cross section. So for the shear force, it will be EY times BZ. I'm taking a moment about this point. BZ is acting here, the EY is the distance, so it is. So we are looking at the counterclockwise. Let's take the moment of all the shear force and be very careful with the sign. It is going to be, if you use use the same sign like this, we don't have to worry about it, everything is going this way. So it will be Q1 times B times B over 2, everybody, okay? Q1. Q2 will be Q2 times B over 1/3 B plus Q3 times B times B over 2 plus Q4 times B times 2/3 B. That is the equation. Now looking at this figure, I am saying Q1 times B, the arm is B over 2. This is Q2 times B, the total shear force, the distance is only 1/3 of B. Again, this one is 1/2. And this is 2/3 of B. And everybody is going the way I have written, according to this figure. So I'm going to take B square outside. Now Q1 over 2. When I substitute for Q1, what is the Q1? Did we solve for Q1 something? When we solve Q1, what was Q1?
-112 BE over B.
So we have to put the negative sign. You know why? Because that is the correct answer. For Q1, see, Q1, if you assume this way, the value is -1/12 VCP. Then you turn around and say, okay, it's a negative sign, that's why it's going this way. If you want to say this way, with the positive magnitude, positive number, then it becomes a clockwise moment, okay? So we have Q1 times the distance is the counterclockwise moment. You keep it like that, but when you substitute for Q1, you have to use this. So I'm going to take VZ over B as a common factor. You are going to see a lot of VZ over B coming. So here there is a factor 1/2 here, and then it's going to be -1/12. Think about it, why minus? Because Q1, if you assume Q1 this way, then its value is -1/12 plus Q2, there's a 1/3 factor here, 1/3. Then Q2 was positive, so it's going the same direction, 7/12 plus Q3 has a factor 1/2. Okay, it's a factor 1/2. And what is the Q3? Q3 equal to -1/12 again. And finally, Q4, 2/3 coming from this, and then there is a factor of -5/12. So I don't have this calculation here. I took a moment about some other point, which is now looking back, that's better than this. Okay, anyway, let's anybody can do the calculation quickly. This is VZ over B, VZB, so VZB, there's a 12 common factor everywhere, so I'm going to take it out. There's going to be 1/12 plus 7/3 minus 1/2 minus 3. Let's see what happens.
The first half is going to be negative.
What?
That first half is going to be negative, right?
Yeah. And that should be -7.
Okay, let's see what happens. So, what is the answer now? -2, -half, -1. This is -3 over 3 is another -1. So -1, -2. Okay? And then this is 12. So minus VZB over 6. I'm okay with whatever you guys say is fine with me. It will always lead to the right answer. Okay. So first thing we notice is negative. What does it mean? Ey is, okay, this is equal to B Ey. See here, Ey times Vc. So Ey is negative B over 6. Ey is negative B over 6. What does negative means? It's not this way, it's this way. Because you assume Ey going this way, but Ey is negative, so you have to come up with the other way. That is one thing. The distance is only B over 6. So you are within the box. And B over 6 happens to be the center of the square. If you look at this distance, so if you look at the center of the square, the distance between these two is actually B over 6. Because this is 1/2 B. If you take off B over 3, the remaining distance is B over 6. So negative B over 6, from the centroid, if you go negative B over 6, it is the shear center is center of the box. You know, the square box is there. So this is the shear center. I got the same answer. I took moment about some other point, but still. Could I have predicted by looking at it? I'm not sure. But now looking back, I think it makes sense. So in this problem, you are asked to find the shear center. First, you make the judgment the shear center has to be along this axis because of symmetry, but you don't know where. So you apply the shear force. See, now you have to apply the shear force Vz. In this problem, you don't apply shear force Vy because Vy, we know it has to go through the symmetric axis, so you don't need it. So you apply a Vz at some location, we don't know where it is. Then calculate the shear flow, starting with Q1. So there are two unknowns, Q1 and Ey. Two equations are, angular twist should be equal to 0. That will solve for Q1. Then take the moment equation and give you now Ey.
So if we knew going back based on problem 1, and we had a rotation,
Yeah.
the VZ should counter-rotate and make it 0.
Man, that's why, see that I didn't erase this.
Got it.
That was the reason I didn't erase this. So what was the name?
Rick.
Rick says, actually you look like Dr. Rick Lent. So Rick says, that's why I didn't erase the theta. I boxed it and kept it all the way. So what he says is, let's calculate what. So you did the first problem. So when you did the first problem, where we apply at the centroid apply a Vz, we found an angle of twist this way, okay? So to counteract it, I have to apply a torque the other way. So let's see, the torsional rigidity of a square box section. If you want, let's do that from the fundamental. So if you apply a torque T, okay, stringers don't take part, okay, so the shear flow will be simply T over 2A bar equals T over 2B square. T over 2B square. This is a torsion, I'm solving a torsion problem. I'm applying a fictitious torque T and see what the shear flow is. T over 2B square. The angle of twist will be equal to 1 over 2 G A bar. A bar is B square, GT, the formula. The shear flow is constant, which is equal to T over 2B square. And then the sum on the length, it is 4B. 4B is the total length. And if you simplify this, it will be what? Somebody quickly do me a favor. T over B cube GT. T over the 2 and 2, 4 will cancel. So T over B cube GT. So now we go back. So this is the torsional for a torque. This will be the angular twist. So we go back and equate the old angular twist. T over B cube GT. If equate this, I can find that what torque I have to apply to counteracts. It happens to be Vz times B over 6. So the torque I have to apply to this to counteract the angle of twist. Which way I have to apply? Remember the torque, the angle of twist was this way. So I have to apply a torque other way. A torque of Vz B over 6. Okay. So how do we apply a torque of Vz B over 6? So what I do is, I calculate a distance B over 6 from this location. I apply equal and opposite force, Vz. See, this is the torque, look at the torque. This originally was there before. Now I need to apply a torque this way. So what I do is I apply a reverse force here which is equal to Vz. And at a distance B over 6, I apply another force. So this torque will counteract the thing and prevent it from rotation. And this force will cancel. So now what exists is this, and the distance B over 6. So it says if you apply a B over 6, a force Vz, it will not go. You are good to look. So if you ask for shear center, you don't have to go through all these things. You could, after you find the angle of twist, you can do the, calculate the torque to nullify it, and then I don't know how many of you can think of this. The torque has to be resolved as a equal and opposite force, so that you can get rid of this force. Move this. Basically, we are moving this force from here to here. That will, so that this becomes a shear center where they would be. I think this problem I like it because it brings out everything you need to understand. Unfortunately, I don't know, for some reason books don't have this problem. They have a good problem, but they're so busy. You get caught in the busy work, so you don't understand. The concepts become buried under the calculation. So you kind of get so tired, you don't even want to learn. So that's why I made a square section. I didn't put numbers here, because if you put numbers, you get caught up in the numbers. If you keep the symbols, that way you can keep track of what is happening. All right. I'm tired. I'm sure you are also tired.
You got plenty of homework to do.
Yeah, the homework I looked at it. Frankly, when I assigned, I didn't even look at the solution or how to do it. I just assigned them because it's the back of the book. Come to think of it, I should have made my own problems.
Still do that.
Huh?
You can still do that. There's still time.
Try your best. I know it's a very, very, I looked it up very long. Just keep trying.
So are those going to be what's expected on the exam?
I think the exam will be much simpler like that. Simple calculation.
So not multiple thicknesses and different G's.
Yeah, I know. But I don't want to say anything wrong because I can't go back. Never say no for anything.